Physics Penguin.
Welcome to Physics Penguin. This week we are looking at two more special types of resistor, the thermistor and the LDR. So let's play detective. What does a thermistor do? Look at the word. It's made up of two parts, therm and ister. That's the ister part first. Let's have a look at that. That's telling us that the component is a type of resistor, a part of the circuit that alters how much current can flow through it. The therm bit refers to thermal or heat, so a thermistor is a heat-sensitive resistor. It changes resistance depending on temperature. Whoa there, Physics Penguin, we've already had that. The filament lamp changed resistance when it got hot, and its resistance got higher. Well, yes, that's true, but thermistors work over a wider range of temperatures, and at GCSE they all decrease resistance when they get hot. A thermistor will allow a high current to pass when it's warm. So what about the LDR? Well, that stands for Light Dependent Resistor. This is a resistor that has a resistance that depends on the brightness of light. When it is lighter, the resistance gets less at GCSE. So let's have a look at some graphs to show how temperature affects resistance for a thermistor. There are no numbers on these scales because each thermistor is different, but the shape of the graph is the important bit. As temperature goes up, resistance goes down. However, the graph isn't a straight line. When the temperature is very high, increasing it a little will reduce the resistance, but not by much. The second graph is actually pretty similar. As it gets brighter, the resistance gets lower. But when it's already bright, increasing the brightness of the LDR doesn't really do much. So finally, what would you actually use these things for? Well, they're both very useful as sensors. Imagine this thought experiment. Cue strange music. You are working in a greenhouse, but you are only a little penguin and the windows are very high up. In the day it can get very hot for a little penguin and the plants will wilt. You need to open the windows in the ceiling, but they are out of reach. A thermistor can detect when the temperature gets too high. All you have to do is set up a circuit where when the current leaving the thermistor hits a certain level, the motors on automatic windows will work and hot air will escape. If it cools too much, the current will drop and the motor can operate the opposite way and close the windows. So, what if you wanted a light in there so people could work at night? Well, we could use the LDR. If it gets dark, the current from our LDR would be low. We need a circuit that detects that and switches on a light. However, what would happen if your LDR was in the area covered by the light? Just think about it. It's dark, so the light comes on, so the LDR switches the light off. So it's dark, so the light comes on, so the LDR switches the light off. So it's dark, so the light comes on, so the LDR switches the light off. So, well, you get the idea. It's a disco. Well, that's enough of that. Time to have a go at some questions. Use the worksheet from the description and pause the video while you do. Welcome back. Let's have a look at the questions from the worksheet. Question 1 asks for the symbols for an LDR, diode and thermistor. If you didn't see last week's video on diodes, check the playlist. Well, here they are again. The thermistor is the resistor symbol with what looks like a hockey stick through it. You can imagine the stick is looking a bit like a thermometer if you like. This is a diode, and I've included an image of what a modern diode actually looks like. Tiny, isn't it? This is the light dependent resistor, LDR. It's just a resistor in a circle with light going in, which is pretty much what they look like. Question 2 is in the table. So what has lower resistance when you have a positive PD? That'll be the diode from last week. It has very low resistance in one direction, but massive resistance in the other. What do you have to do to a thermistor to make it have a lower resistance? Well, you warm it up. High temperature equals low resistance for these things. What mysterious component gets less resistance when it's bright? Well, that'll be the LDR. Light is low, black is big. That's a way to remember. Light low, black big. Question 3 looks tricky, but it's asking you to imagine an experiment. In the circuit we've got two parts. A bulb connected to a 6-volt power supply and an LDR connected to an ammeter. The first two things to say is that the bulb will light up all the time. It isn't really affected by the LDR, so it just glows constantly. The LDR is going to act as a resistor, but its resistance depends on brightness. You have to say that lighter is less resistance or darker is higher. What does that mean for the ammeter? When it is light, the ammeter will read a high reading because resistance is low. When it's dark, it will read low because resistance is high. We've got a light meter basically here. The question asks about testing the curtains. So what would this do? Well, if the curtain is between the bulb and the LDR, then you can compare different curtains and see which ones stop light best. Finally, it asks about being a fair test. So let's think. What would mess up the experiment? You only need a couple of these. Don't alter the power supply. Don't change the distance between the bulb and the LDR. Each set of curtains should be placed in the same position and be the same size. The room you test in should be dark apart from the test bulb. Don't change the test room or open doors during testing. Repeat readings to get a mean result. And the temperature should be constant because silicon devices are affected by temperature quite badly. Finally, question 4. This is tricky and is an example of something we need to look at called a potential divider. Let's take it steady and spot where these 5 marks might come from. Why does the voltmeter reading change? First point, there's 6 volts shared by the resistance and the LDR. The second point, if the LDR had a resistance of 75 ohms, like the resistor, then the PD would get shared equally, so that's 3 volts each. If there was no resistance in the LDR, then the full 6 volts goes across the resistor, so that's the reading on the voltmeter. In reality, we don't actually know the resistance on the LDR, but we can see that lower is bigger on our meter. Mark 3, what decides what the resistance of the LDR is? Well, that's brightness. The brighter it is, the lower the resistance. Mark 4, we have to talk about electrons in the LDR. It says so in the question. What happens in the LDR when it gets bright? Well, light energy is getting absorbed by the silicon in the LDR. That energy has to do something, and in this case it goes to the electrons trapped in the silicon material. The electrons gain energy and can break free and start moving. moving charges is current. Mark V, having extra electrons available in the material, makes its resistance very low. So bright light frees electrons and lowers resistance. Now that is a tricky question, so don't panic if you didn't get it first time. If you can achieve 3 out of 5 on this question, that would be on track for a level 9 at GCSE, based on the first 2 years of the new GCSE system. Well, that looks like it for this week. Don't forget to stay subscribed to be updated with new videos. Until next time, this is Tata from Physics Penguin.
Physics Penguin.